right, our last topic is rational exponents. So if you have a number to a fractional exponent, you can rewrite that as a radical. So in our example here in the box, a to the n over m, this m becomes the index of your radical, and then the number on top is your exponent, so the n that stays on top there. So we can kind of go back and forth between exponential and radical form. That's what we're going to do on 15 and 16. So number 15, we want to write these in exponential form. I don't want to simplify them, I just want to rewrite them. So for example, like the cube root of 27, I know that's 3. I know that. Okay. This is 27 to the first. So what we can do is we can write that as 27. Your exponent goes on top, and then the denominator is this index. So the cube root of 27 is the same thing as 27 to the 1/3 power. Okay. Often I use this shortcut when I'm using my calculator because the cube root button takes more work to get to. It's in the math menu and you have to dig a little further. So when I'm trying to go in a hurry, sometimes I'll just use this instead. Okay, the next one is a square root. The index is 2. So we've got all these exponents, x to the third, y to the fifth, and z to the first. Those are going to remain, and the denominator will be the index. So x to the 3/2, y to the 5/2, and z to the 1/2. That's it. All right, in part C, now the 3x, we're going to leave that be. Okay, that is not in the radical. So the 3 is going to come over here in the fraction, so we have x squared, and then the denominator is going to be this index, 3. So x to the 2/3. Now we can clean this up a little bit, because this is x to the first and x to the 2/3. So since we're multiplying those, we can add those exponents. So 1 plus 2/3. Well, that's 1 2/3, but we want that as an improper fraction. So that would be 5/3. If you're not sure what just happened there, I am adding 1 plus 2/3. I'll put it up here. 1 plus 2/3. This is 1 over 1. I need a common denominator, so I multiply both of these by 3. So what I'm really doing is taking 3/3 plus 2/3, and that's where this 5/3 came from. Just adding your exponents. Okay, now we're going to go the other direction. Now we just want to take these and write them in radical form. They didn't really tell us to do this, but I don't really care to deal with negative exponents. So remember, to get rid of negative exponents, we just drop them down like that. So that takes care of that negative. And now this 2 right here in the denominator, that is going to become our index. So we are taking 1 over the square root of x squared minus 7. The 1 is still our exponent, so x squared minus 7 to the first power, which we can just leave it at this. Okay, in part B, the negative 3, that gets to stay out. That's its own thing. Okay, but both of these have the 3 in the denominator, so we can say that's the cube root of b to the first and the cube root of c squared. Now, since those are both cube roots, we can put them under the same radical and make it negative 3 cube root of bc squared. Okay, on the next one, we are going to first change this into a fraction because there's not much we can do with the decimal. 0.75 is the same thing as a to the 3/4. So we're going to take our denominator, that becomes the index, so the 4th root of a to the 3rd. And we're going to do similar here on part D. This is going to become our root, so we have the 5th root of x squared squared, which is the 5th root of x to the 4th. You could have also multiplied at the beginning, so another way you could have done this is multiplied 2 times 2/5 and said this is x to the 4/5, and then brought the 5 out as the index. Doesn't matter which way you go about that. Same answer. Okay, here's where we're going to put it all together. We want to simplify these things. Okay? So we want to get an actual number. Hopefully we can do this. So on A, negative 125 to the negative 2/3 power. The first thing I want to do is get rid of that negative exponent. It makes me very uncomfortable. So this is going to be 1 over negative 125 to the 2/3. All right, now most of us cannot do like 2/3 power in our head or anything, so let's put this in radical form. The 3 in your denominator, that's your index. So this is going to be 1 over the cube root of negative 125 squared. Now, I really don't want to do 125 squared in my head or on paper. I didn't even bring a calculator with me over here. So remember from a previous video we talked about this square. We can scoop this out. So this is the same thing as 1 over the cube root of negative 125 squared. Now, the cube root of negative 125, I can do that. I know that in my head. That's negative 5. So we have 1 over negative 5 squared, and I can also do this in my head. 1/25, final answer. Okay, let's look at C before we jump in with all those variables. I don't know what to do with those yet. Okay, we have the cube root of the 4th root of 27. Okay, so we can rewrite this. We can multiply our indexes. This is the same thing as the 12th root of 27. And then, well, there's just not a whole lot we can do with that. So I think we're actually done here. Yeah, I mean, because if you do a factor tree on that, there's definitely no groups of 12 or anything that you can pull out of that. So we'll just leave it as the 12th through 27, or if you want to write it as 27 to the 1/12, if that makes you happy, it's the same thing. Okay, in B, I think what I would like to do, there's multiple ways you can go about this. I think what I'd like to do is put everything together and then I'll work on cleaning it up. So first I'm going to multiply 4 times negative 3. And then x squared and x to the negative 1/3. I'm going to add those exponents. So 2 plus negative 1/3, that's going to be 5/3. And then I'm going to add these exponents. So y, let's see, I might have to do this one over here. 3/2 plus negative 3/5. I need common denominators. So 15. So 9/10. Is that right? I think so. 15 minus 6 is 9. Yeah, 9/10. Okay. Here we are. Boy, and there's not much else we can do with that. We've got it combined. There's no negative exponents. So you can leave it at this, or if you wanted to write it as radicals, I guess you can do that. Negative 12, cube root of x to the 5th, 10th root of y to the 9th. Honestly, I'm not sure what your book does with it. I'm guessing that they do more of the fraction ones. So if you're checking answers in the back of the book, which I definitely encourage you to do, these are the equivalent things. Okay, last one. 3x plus 2 to the 5/2 and 3x plus 2 to the negative 1/2. Notice since the bases are the same, I can add my exponents. So this is going to be 3x plus 2, 5/2 plus negative 1/2 is just 4/2, which is the same thing as 3x plus 2 squared. And I'm totally fine with that answer. If you really wanted to FOIL it all out, you definitely could, but you don't have to. So, on all of these lessons, there are additional videos of, that come from your textbook website. So if you use this shortcut link or this QR code, it'll take you there. And if, example number 17 didn't make sense, if you didn't like the way I explained it, there's another video on there of somebody else explaining it that you might like better. I highly encourage you, as you're doing the homework, to check your answers in the back of the book. You can also use CalcChat to see the worked out solutions. Please do not rely heavily on that. You need to be able to do these on your own. If you have more questions on these, come see me at the help session.